theory gas law. So the three fundamental gas laws, which are Charles's law, Boyle's law, and Guy-Lussac's law. So these are great gas laws, but they don't count for everything. For instance, what if we were trying to figure out the number of moles in a gas system or something like that? So what is the ideal gas law? That's what we're going to use for this. So the ideal gas law is this equation, PV equals nRT. P stands for pressure, which is in atmosphere. V stands for volume, which is in liters. N stands for the number of moles. R stands for the gas constant, which in this equation is 0.08206 atmospheres per liter mole Kelvin. And so it's a scary looking unit, but it just cancels out the other units around it, so things are right. And then T is temperature, which is in Kelvin. So we're going to look at some example problems now. So example problem 1, student measures the temperature of a 1 liter container filled with 2 moles of carbon dioxide gas. When the temperature reaches 250 Kelvin, what is the pressure inside the container? Alright, so for example problem 1, we're going to want to start with our gas equation. Ideal gas law, PV equals nRT. And so we're given a few things. We're given that volume is 1 liter. We're given that N is 2 moles. We're given that T is 350 Kelvin. And we're looking for P. So why don't we just write everything in and plug in jugs. So we'll start out with P times 1 equals 2 times our gas constant, 0.08206 times 350. And so if we multiply this out, we will get that pressure is equal to 60 atmospheres when we account for sig figs, of course. Problem 2. A chemical boils at 290 Kelvin. It has a molar mass of 56.2 grams per mole. 100 grams of it are placed in a previously evacuated container at 200 Kelvin and then heated to 300 Kelvin. The pressure inside the container is 10 atmospheres. How big is the container? Alright, so for example problem 2, we're given quite a few things. And it looks a bit complicated at first. There's a lot of numbers and stuff. So why don't we start by approaching what temperature we're measuring at for our gas equation. So we're given a few temperatures. We're given a boiling point, 290 Kelvin. We're given a starting temperature, and we're given a final temperature. So the important thing here to note is that our ending temperature is going to be greater than our boiling temperature. So we know that the entirety of the substance has boiled and is going to be in gaseous phase. So we can ignore the other two temperatures and just know that our temperature is going to be equal to 300 Kelvin. And then of course we're using our ideal gas law, which let me write that up here. Alright, so now what about our next thing? We're given temperature, we figured out temperature. We're given pressure as 10 atmospheres. Then we obviously know R, we know our gas constant. We're being asked to solve for V, so now we need to find N. So we're given a mass for N, and then we're given a molar mass. So what we can do here is take our given mass of 100 grams and multiply that out by our molar mass. And if we do that, we are going to get 1.78 moles. So then we can just plug everything in and chug. So let's start out with 10.0 atmospheres times our volume equals 1.78 times 0.08206 times our temperature of 300 Kelvin. And then what we get here is 10.0 times our volume equals 43.8, meaning our volume is just going to be equal to 4.38 liters. So that's our answer. Thanks for watching. This has been Kieran Lyons with the Ideal Gas Law for Ms. Wilson's AP Chemistry class.